Good afternoon. Do you need a stretch break? All right, we're going to talk a little bit about the application of Far-UV for the outbreak of tuberculosis that occurred in New York and a lot of urban centers in the late 80s, early 90s. We began reapplying upper room 254 nanometer technology. We reviewed all the science. We looked at the various equipment that was out there. We did a lot of study about that, and we recommended improvements. So I have in my head kind of a checklist of some of those things when we were applying over 1,200 fixtures in the TUS study, TB UV study that was mentioned by Shelley earlier in the day. So we really learned about how to characterize equipment, how to apply it safely, how to look and ask the right questions. And Mel First, a scientist at Harvard that really wanted to study all the equipment and to characterize it, was really the one who kind of drove a lot of this early work in that area. And that's what we're doing right now. We're trying to assess what is the, how do we actually apply this? How do we begin to think about this? Our ASHRAE committee on upper room UV GI applications is also looking at what about the new sources that are coming along the line, and when can we then begin feeding those into application. So during the pandemic, I learned about the excimer lamps. I'd really not known that much about them, and decided to educate myself a little bit about it. But at a busy academic center, finding space to do anything is very difficult. My garage was full of files from previous moves of offices and things like that. So I had no space to really do this. But I came up with a solution with a lighting company out in Long Island City, who are part of my collaborators here on this study. They had the raw space. They knew how to hang lighting equipment. And so we were off to the races. And so what we wanted to really find out is, how do you really apply these things? We were hearing that some of the sources would be only on for a few seconds, then they'd be off for several types of things set in order to be able to meet the threshold limit value. The threshold limit value actually changed during the pandemic. It was at one level, and then in 2022, it increased for the 222 because it was looked at and thought to be more safe. And so it allowed the application of that to rise higher, which is a good thing. And so one of the things, different people would provide equipment to us, and then we would put it up and try to test it. Here you'll see a slide of Dr. Sliney and a couple of the team trying to look at measuring these devices at various eye level heights. Part of what ASHRAE has recommended is what is the eye level height you should measure for standing or if you're seated. Those are going to be two different types of things. And of course, with the upper room UV, we're going to also point the sensor upward to find out what kind of incident of UV you would have accumulated on the top of the head. And so that is part of the exploration that we did during our studies. Let me see if I can figure out how to go back. Yes. We built a photometric chamber to be able to look at the source, and then looked at various types of things that people would want to know in the field to show that this was actually working. And so during the pandemic, we've got some dosing dots that were specifically designed for 222 before they became commercially available. And so we started using those to explore dosing of those types of things to see whether there'd be stability and also repeatability in it. We also looked at a vial system by which we could do a biomarker with the B subtilis, either at a 2-log or a 3-log. I'm blanking on the term of it, but anyway, it was going to be inoculated, so you'd have at least 2 logs or 3 logs in this vial system, and then you could expose it, and you'd either have a no, you didn't get enough dose, or yes, you did get enough dose. So it would be a kind of an easy way in the field to have a biosafety level 1 organism kind of in a little tube that you could do some verification in a field situation. And this is really part of what is going to be needed, I think, to convince end users that the systems are actually working, doing some demonstrations in various settings and trying to build confidence that this type of a system is working. I think we have a lot of good scientific evidence, but in the application side, we need to build how do we actually do this and apply it. And we also looked at some of the things about how do you diffuse the output from the fixtures, because as you know, the isotropic is a very concentrated beam, and to have several of those little pools of UV, you really want to have a more uniform field, but that also drops the output of the fixture as well. So those are some of the explorations that we did, is looking at different types of diffusing media and compared different types of meters. Really, to have a handheld radiometer is really key to doing some of these field types of studies and installations. And then we used the UV confirmed device to look at dosing, and we did it for 2 log kills or 3 log kills, and compared the 222 to 254 to 275, and showed that it could work across all those different wavelengths. And so it was a pretty, on an exploratory basis, it looked like a pretty good solution to trying to verify with a biomarker in the field this type of a solution. I think it would really need to have further study before it became a standard practice, but I think it could be something that could be explored further and seeing if you could get stable results. The dosing dots are used quite frequently by companies now to show that you're getting the UV. We also use the Pantone scale to be able to document what the color of each of these dose were, so that you could compare from time to time whether you were getting the same level of UV on these dosing dots by comparing the Pantone number with the color Q meter. And then we looked at safety. How do you measure safety? During the pandemic, the IES released RP44, and it talked about using the field of view cone to be able to do your safety, eye-level safety measurements. And so we began to use that in our documentation. You'll see that here you have somebody seated with a meter at the eye level height. And then we did it also standing up in a grid pattern. This is typical how we would do upper room types of characterization of spaces as well. And we did some comparison between with the sensor unhooded and hooded at the same time. You'll see, and in this situation, we were looking at, whoops, sorry. I turned that off altogether. There we go. And let's see. This is a LED fixture here. And this was an interesting unit. If you didn't have it precisely leveled, it would not turn on. And so that was one of its safety things. Is that my cue to end? Oh. All right. And we tried hanging all these different types of units in this raw space. Here you can see the B1 modules integrated in a 2x2 troffer. And, you know, they would be on, one would be on for a while, and then the other one would trigger. So it'd be back and forth, the triggering. And if you blinked, you would probably miss that actually being on. And then, of course, it's integrated now with the lighting panel as well. And I think this is probably where a lot of UV is going to be working, is you're going to start seeing hybrid systems where it's integrated with standard lighting, and it'll just kind of be part of the overall planning of lighting systems. I think it really makes a lot of sense in that regard. And these are some of the results of our testing from the FOV hood. When you pointed the sensor directly up here in the middle, you would find the irradiance that you would find at those levels that's kind of directly underneath the source. And then when you did it on a horizontal basis, like at your eye level, course, the eye is protected by the brow of the head. And so here you see that there was very little coming into the eye itself with the meter that we were using. And we also started to do some microbiology, looking at what you could actually buy online with E. coli types of things, and to test it with the Far-UV and at different dose rates. And you can see the controls are up at the top, and after exposure to the Far-UV, these were essentially clear. There's maybe one or two colonies here. So it gave us a certain level of confidence, since we didn't have a big micro lab to study a lot of this. It allowed us to be able to start to make some judgments about the use of this type of technology. And then the idea was, how would you actually convince a customer to use this? And so there's, during the last pandemic or outbreak of TB, we worked with Acuity Brands, and they developed they modified their lighting software package to accept germicidal UV. And so now this software package can do all wavelengths. And so you can plan a UV simulation for 222, 254. You can select what the wavelength is, and it'll do the calculations based on that. And so we thought about, a coffee bar. If you can imagine being at Starbucks, you have your computer there, somebody sneezes next to you, what kind of decontamination could you have from having one of these lights overhead, and what kind of levels of decontamination could you get over a period of time? Oops. So this is the simulation that was built by Mike Kruger. He helped us to mock up the alcove where we had the lights hung up here in this alcove. We actually only used one of the lights directly down onto the surface of the snack bar. And this is kind of the look of what the fixtures look like when they're hung. This is like one of the Far-UV fixtures. This is more of a can type of UV fixture. And so we used one of these as our source for exposure of the dosing vial, the dosing dots and the vial. And then we had different meters that were recording what the dose was that was being exposed there. And you can see some of the results that we have here. And the vial, after it was exposed, you flip the top, you shake down the liquid inside, and then you incubate it over a 24-hour period. And if it turns purple, then you've got your 3-log kill. If it's yellow, that means you didn't achieve your dose. So it's kind of a no-brainer in some ways. It gives you a certain level of confidence, but not necessarily the same as if you had a laboratory doing all the testing. It's just to help people in the field to try to verify the performance of what they are seeking to do. And these were our results. So we got on the, we were able to get on the surface a 3-log kill over a 24-hour period. We'd let it run, and then we had like 63 millijoules per centimeter squared. In the simulation that we have here, the red zone was like 71 millijoules per centimeter squared on this surface. And so what we actually measured and what we actually achieved was pretty good. Wasn't perfect, but it was pretty good. And so these are the types of things I think you could probably begin to refine. This was just all exploratory. It's not necessarily scientific, but it's something that gives you kind of a framework of things that could be done to try to work with customers and clients on how to apply these things and then verify that they're actually working to a degree within the field. So that's part of the purpose of this. So I think that there's a lot of opportunity for the Far-UV area. I think we're building the evidence chain there. I think that's one of the steps that we are working on right now. There's a lot of good information on reflection of 222 off of various building surfaces. So we have all that can be built into the models. We're starting to learn a little bit through some of the chamber studies, the dosing aspect. I think that as that becomes clear, that will help people to understand, oh, if I have this type of a room, I'll need so many of these sources in here to be able to inactivate the air. These were more oriented towards surfaces. Of course, in healthcare, that's one of the primary areas that people are interested in, is how do you really deal with the surfaces, because that's where the healthcare associated infections come from. And that's how really hospitals are rated. So understanding how this technology works with other technologies is going to be a very important part of that solution. So thank you for your attention.